So for problem number 57, we can identify, since the tangent is negative and the sine is positive, that would occur in quadrant 2, so I already put that there. And then what we want to do is we want to put a point out here, and we want to identify the coordinates of that point, and we'll do that in a moment. But the first step would be to build a triangle. Build a triangle. Actually, that's a second step. The first step is to identify, well, what quadrant are we in. So the second step is to build a triangle in that quadrant. And when we build the triangle, we put a point somewhere in that quadrant, and then from that point we draw a vertical line straight to the x-axis, and then from that same point we draw a diagonal line straight to the origin, and then we complete the triangle, and we just put theta right there. Now, what I mentioned, hopefully I mentioned this in class, that when we label the triangle, so the third is label the triangle. So when we label the triangle, we use our knowledge of SOHCAHTOA. So this is the third thing, SOHCAHTOA. Since we're given the tangent is opposite over adjacent, then we know the tangent is opposite over adjacent. Then we know the opposite leg has a length of 1, and the adjacent leg has a length of 3. So we can label our triangle. It really makes it easy to find the values of the trig functions. Now, what I mentioned in class is that we want to figure out what are the coordinates of that point right there. And if we move from the origin to the left 3, then the x-coordinate would be -3. And if we move up 1, then the y-coordinate would be +1. Now, how that helps us is that we can just label that, even though side lengths of triangles aren't allowed to be negative, we can label it a negative number because that's going to help us find the trig functions. And but the next thing we do, fourth, would be to use the Pythagorean theorem to find the other side. Use the Pythagorean theorem to find the third side length. So let's do that. 1 squared plus 3 squared equals the hypotenuse squared. And so we get 1 plus 9 equals the hypotenuse squared. And 1 plus 9 is 10. So if we take the square root of both sides, we get the hypotenuse has a length of radical 10. So we can just label the length of the hypotenuse radical 10, and then we can use our knowledge of SOHCAHTOA. The sine is the opposite over the hypotenuse, so therefore the opposite leg is 1, and the hypotenuse is radical 10. I told you when you are finding all 4, 5, 6, whatever trig functions of angles, I don't need you to rationalize the denominator. The cosine is the adjacent the adjacent leg over the hypotenuse, and the adjacent leg is -3, and the hypotenuse again is radical 10. The cosecant is the reciprocal of the sine. The secant is the reciprocal of the cosine. And the cotangent is the reciprocal of the tangent. So let's just make sure we got our positive angle or positive values, sine and cosecant, and all the rest are negative. Check. We're good.